come across some cool new method in a paper and you want to try it out, or maybe you want to make a modified version of it, or maybe your advisor gives you a paper and tells you to try out the method. Well, there's typically not enough information in that paper's method section to just really just like dive in and do it right away. Instead, you have to do some sleuthing work. So I got an email from someone asking about how to figure out how to recreate an experiment, a protocol based on a paper. And this is something that I've encountered a lot over the years in training. And don't worry, it gets easier, but it's always going to involve a lot of work typically. It's not just like they're going to give you a recipe straight out. There are things that you can do though, like trying to find updated versions, trying to find similar protocols, and then using your critical skills, your critical thinking to figure out where you can substitute various steps for maybe equipment that you do have if you don't have a certain piece of equipment. Or maybe you can swap out a technique for a technique that you have more experience in, like one of the little parts in the protocol, one of the many steps of the protocol. Then you have to figure out, okay, how do I make these solutions? How much of each solution do I need to make? So there's a lot of decision making that you'll need to do along the way. And there's going to be a lot of Googling. And so if someone tells you to Google, if a scientist tells you to Google something, they're probably not just trying to like wave you off or be lazy. It's like literally one of the biggest things that you do as a scientist is learn how to Google well. And so Googling is like one of the key skills that you learn in grad school, I have to say. And Google every day. But in addition to Googling, we also get skills that we developed over the years and get a sense of what details matter, what details don't matter. And so I just want to help kind of pass on that knowledge of how I go about when I need to figure out how to design an experiment and carry it out based on a scant amount of data in that method section. And so unfortunately, method sections of papers are typically, they're not like recipes. It's not just like a cookbook, do this, then do this, then do this. Instead, they basically give you the bare minimum that you need, and then you have to figure out all the details. And so sometimes this can be a real pain, but it also allows you to use more flexibility. If they were to give you, say, like step-by-step instructions for each little step and like each individual volume that you need to pipette, well, it probably wouldn't be directly applicable to your experiment anyway, because you'd have to adjust things. But mostly it's just a pain because you have to figure out how to do all the different steps. So it's going to take a lot of Googling, critical thinking, detailed planning, and because you're trying to figure out everything, there's probably going to be some troubleshooting and optimizing. And so as I get into, you really want to make sure you have good controls, maybe like a positive control. You could try to recreate the experiment that they did. So you want to make the most of all the information that they give you. So most of the time these days, the really good information is in the supplemental section of the paper. So the methods section in papers, often they're just really brief, and it says like for detailed methods, go to the supplemental. Or sometimes they don't even have the methods in the main paper, and it drives me crazy. Also, sometimes with like older papers, I think it was like science that have the methods like in their footnotes, like in really, really tiny text. So basically the methods have often been overlooked and underappreciated. And I think that the methods are one of like the best parts of the paper. It really helps you get a sense of what the experiments were performed. Sometimes it might even affect how you interpret the results of the experiment. In the case when you're trying to recreate someone's experiment or do a similar protocol, it's crucial for trying to figure out what the heck you should be doing. So use the most of all that information that they give you. So in the supplemental though, one of the things, so because it's overlooked a lot, it's also overlooked a lot in the editing and proofreading. And so there might be typos in there, more so than you would find in the main section of the paper. I have found lots and lots of typos and lots of supplemental sections, but I'm still grateful for the supplemental sections. But you want to just keep your critical thinking skills on and keep an eye out for when things seem a little weird. Okay, like another place where you might be able to find additional information is if the paper has a preprint.
So a preprint, these are papers that have like not gone through peer review yet. And so often what happens is people will post a preprint well when they submit their paper for review at a journal. And so when you submit a paper to a journal, then it goes through this like peer review process where the journal editors, if they think it might be worth publishing, then they send it along to peer reviewers who are fellow scientists who are then going to take a look at it, say yay or nay, or maybe, but change. But we want you to answer these questions, maybe perform a couple extra experiments. So, but okay, so people often post their paper to a preprint server like bioRxiv, which has grown in great popularity over the last few years. And these servers are open access, so anybody can look at them. So you can always see the preprint, even if you can't see the published version of the paper. You can also often download the supplemental data because it's often like uploaded as a PDF. So from when a paper is published, often you can download the supplemental without actually having access to the paper. So you get the best stuff for free sometimes. But anyway, so sometimes people post a preprint when they're submitting their paper to a peer-reviewed journal. And other times people just post a preprint and then later maybe they'll publish part of it in a journal and then part of it in another paper, and that sort of thing. So what happens is you can have that where there's experiments in the preprint that actually don't make it into the paper. Maybe they're going to make it into a separate paper or something like that. Or there might be just additional data in the preprint that isn't in the main paper. And so you want to keep an eye out for that sort of thing. There might be more information that didn't make the cut for that final paper because there's word limits and all this stuff like that. But when it comes to this preprint, it's a lot more flexible. So you might find additional information there. So once you find that information, you want to try to figure out like what each step in the protocol is there for and what each reagent is there for. And so this is something that I emphasize over and over, like no matter what I'm doing, like if you're doing something based on a kit, try to figure out like what each thing is there for. It's going to help you in so many ways if you need to troubleshoot various things like that. And in this case, it's really crucial to know what things you need and which things you don't need, what things you can substitute, what things you can't substitute. So this can be really hard at first because you don't have that like sense yet of what's for what and what's important, what's not important. You don't it takes time to build up these skills. It takes like doing a lot of getting this kind of sense. So don't feel bad if at first it's really, really hard. Even later it can be really, really hard, especially if it's a paper or a technique in a field that you're not used to. So just be patient with yourself and try to talk to other people who maybe have done parts of the protocol. So these protocols often have a lot of parts, and maybe they have experience with like one aspect of it, even if they haven't done this overall protocol. So try to talk through things with various lab members and things like that. You don't have to go it alone. So try to find help, and then you will build up this sense. So speaking of like what you can and where you can change things, where you can't change things, one reason why it's really important to know what each step is doing in a protocol is because there's often multiple ways to do something. So you might read a protocol and you're like, oh my God, they have this piece of equipment that I have no idea what does. Like, or I mean, okay, well, you can figure out what it does if you Google or something. But maybe like, okay, I have this piece of equipment. I don't know what it does. I figure out what it does, but I don't have it, or I know what it does, but I don't have it. There's often an alternative that you can use. And even if you do have the equipment, sometimes it's not something that you're that familiar with. So you can use equipment or you can use methods that you're more comfortable with. Um, so for example, for like protein purification, often there's multiple ways to purify a protein. Maybe you want to purify it based on its charge. Maybe you want to purify it based on its affinity for something else. There are various things, and depending on your protein constructs and stuff, which I'm not going to get into, but basically there are multiple ways to go about doing the same thing. And if you're more comfortable or more familiar with one technique, maybe it makes sense to go with that one. Not that it's bad to learn new techniques, but maybe if you're trying to learn this whole overall big technique, maybe try to keep that one part something that you're more familiar with, if it's something that you can easily substitute, or if it's like an equipment that you don't have, maybe you don't have maybe it calls for like a qubit, which is this like fluorescent device that measuring device you can use to measure like protein and nucleic acid concentrations. Maybe you don't have one of those. Maybe you have a nanodrop. Okay, use the nanodrop instead. But no, it's not as accurate. But if the accuracy doesn't matter as much, then it's not a big deal. And so again, this is where having that training, it's going to come. It's going to come. Don't worry. Like it's going to be really hard and overwhelming at first, but over time you will develop these skills to know like when it's important to actually know the concentration, when it isn't important. And again, this is where having a mentor too can be a really helpful thing. Often what you'll see is that people originally develop this protocol and then everybody cites that original paper because that's where they first developed the protocol. But they typically don't do it exactly as they did it in that original paper. So methods papers can be some of like the most cited papers ever. I think like the Bradford paper or like has like for the Bradford assay for measuring protein concentration. I think that paper has like a bazillion citations. But basically people will cite the original protocol even if they're not using it exactly how that protocol was written. And so you want to try to find the most up-to-date versions of it. The first place to go is the authors of that original protocol. If they published a paper afterwards, a later paper that used that earlier paper, they might have then actually optimized it further. They might have published it earlier before they had finished optimizing it. And then maybe later they found out, okay, well, you can actually do it this way or use this different reagent, this different ingredient, and it'll work better. And so then they'll change it. And then if you look at that later paper, you can figure out, oh, they changed it. Or so often what you'll see is that when people cite a protocol, they won't really give that much detail. They'll say like performed as in paper, blah, 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 and then give the citation. This can get really, really annoying because then you can end up like going on like down rabbit holes, like this paper cites this paper, and then this paper cites this paper, and this paper cites this paper, and this paper cites this paper. And you can go end up like getting lost and then end up back in like 1950s on a paper that's not digitized. So it can be really, really annoying. But often what they'll say is they performed it at like this paper, except that we did blah, blah, blah. Sometimes those exceptions are things like just optimization things that would make the protocol work better. Other times, however, those things are specific to the specific experiment that they're doing. So maybe they modified it to be compatible with whatever experiment that they're doing at that time. And so it doesn't impact your experiment. Like you would still want to use the original protocol. Other times, however, you would want to use that, take into account that new modification that they made. In addition to the authors having further versions of it, other people who have used that paper might have made modifications to it as well. And so you want to see where that protocol has been used. So try to find papers that have cited that article. They might not have cited it for the method. They might have cited it for something else. But you can go look at the paper and see if they were using it for the method. A really helpful tool that I like is this web browser add-on called Cite, like Cite.ai. They have a free version as well as a paid version that your institution might have a subscription to. It's a citation tracker, and it's going to allow you to see where an article has been cited, and it also shows you the context of the citation, so you can see if they were citing it based on like for its protocol before you actually go check out the article, or you could just check out the article. If you don't have access to the article, one way to find out if there's a free version is with this Unpaywall browser edition, and it will show a little like green unlocked symbol on the side if there's a free version of the paper. There are also like SciPub, which is free versions of papers, but those are not always legal. So been warned. But I won't tell. Okay, then so that's like the original method. But if you're not like dead set on using that original method, there might be better methods out there. And so if all you care about is finding the experimental answer, maybe there's a better way to go about it. And so don't feel like you have to do it that original way, exactly how they did it. See what other people are doing, and see if there are modified versions of the paper that you might be able to use that might work better for you. Okay, the most helpful thing that you can do if you can find them is to find some sort of methods paper or publish detailed protocols. So this is just a helpful list of some of the various sites where you might find protocols published. So supplier protocols, there's some protocol sites. One that I have really like is Jones, this Journal of Visualized Experiments, because they're going to have like videos for various things. And so these are like peer-reviewed methods. Sometimes they're like people that describe the methods that they did in a paper, in like a video form. And then they also have like educational content, which are more like fundamental techniques. So, for example, if you want to learn about how to do an EMSA, an electrophoretic mobility shift assay, which you can use to measure nucleic acid binding to two proteins in a gel, and I have more on that in other posts. But this will help take you through how you actually go about doing this experiment with the experimental details and everything. Well, assuming you don't get an error message. But so some of the content is like free, and some of the content is you have to have access through your institution or your library or something like that. But if you do, it can be really, really helpful. And sorry, my computer doesn't seem to want to play this right now. Um, I don't know why the video isn't working right now, but it's a helpful site. And you can see that they have other videos on fundamental techniques in this education system section, as well as like applications. So people using these techniques for really specific experiments, like using it for screening for functional non-coding genetic variants. So often these experiments are like way more like focused on one particular thing that you might not be interested in. But again, this is where you can kind of see the fundamental parts and the parts that are the components of it that you could use in your experiment. And it'll help you determine like the actual techniques that you use when you carry out these things that you've only seen on paper. Another useful one I really like is like nature protocols. Again, this is something that you probably have to have a subscription for your institution for most of the articles. But they have, again, really specific papers on specific techniques, but then they also have more fundamental ones. For example, they have a paper on the EMSA, and what's really nice about these is that they have like really detailed information about kind of like the background and the purpose of various parts and the various steps. Um, and they have great detail about even how to handle the various reagents, how to set things up, really detailed instructions. And so these can be really helpful. In addition to those detailed published protocols in like those databases, if you go to like individual labs websites, so maybe the lab that actually published this technique in the first place, they might have the protocols posted on their lab website. Sometimes they're just for, it seems like they're there for like internal for their own lab people, but they're public, so I don't know. But sometimes I've run across those just by Googling or by going to the lab website. Often by Googling, you also find that teachers for like lab course protocols will have those published that you can find, and those can be really, really helpful. Sometimes they're for more like fundamental techniques, and they're not going to be for the detailed part, like all the overall protocol. But remember, these protocols often have like multiple parts, and so if you can figure out each part individually, then you can build together this, piece them together and get a better sense of the various parts, and help you perform this experiment overall, especially because there's probably parts of the protocol that you're super duper familiar with. And so you don't need the full detailed protocol for that, but maybe there's a part you're not as familiar with. And that's where these more detailed protocols can come in really handy. No matter what you're doing, you want to keep that critical thinking cap on, because just because the authors did things one way doesn't mean that that's like the best way to do it or even the right way to do it. So sometimes you might find some methods where you're like, that's not the optimal way to do things. Sometimes there's like lab lore and things where somebody did it, like there was some antidote that if you do this, it makes things better. And that was like zillions of years ago, and no one ever tested it because everyone's like, well, this guy said it makes things better, and I don't want to find out the hard way. Like I don't want to spend my time optimizing. If it works, then oh sure, let's use it. And so then there's these techniques that people are using without any really real evidence. And sometimes these things are like keeping things overnight or doing things in the freezer, things that make your life harder, even though there's no proof that they actually help you. There's also like sometimes people like labs will do things with a certain buffer because that's just what they're typically using. Maybe they'll use a certain reporter because that's what they used in they had sitting around for the rest of their experiment. So basically know that there could be reasons totally non-related to the actual needing to do it for the technique itself in that protocol. And so keep your critical thinking skills on and do it the way that makes the most sense to you and your lab and everything like that, if it's something that you know can be changed. When you do decide to give it a go, though, you want to make sure that you're giving the experiment the full chance to succeed before you go changing too many things, because then you won't know if the things that you changed were why it didn't work, if it didn't work, or if the things that you changed were nothing to do with it and it was something more fundamental to the technique, the other parts of the technique that were coming from this paper. And so you want to be able to kind of like recreate the paper's conditions first, unless it's something where you substituted a step that you like know, like you can do it. Like I can use the qubit or nanodrop instead of the qubit or something like that, where it's not like a crucial part of the experiment. But no matter what you do, you want to have some sort of like positive control so that you know if it works, it works. And a negative control so that it doesn't give you a signal when it shouldn't give you a signal. And so for positive control, sometimes if you can recreate the experiments that the things that they did, or maybe they included some positive controls and you can recreate those. So try to have something where you can figure out, is the technique itself working, or is the technique not working, before you go changing too many things, and trying to figure out, okay, well, I'm getting this weird result with my experimental conditions. I'm testing this condition. Am I seeing these weird stuff because my condition's weird? Is this some cool new phenomenon I found, or is it just like an artifact of the technique because I didn't set things up right? Speaking of setting things up, often one of the details that they will give you is the buffer. So it's like pH stabilized salt waters, and typically they'll tell you like the final concentrations, but that's about it. And so you'll need to figure out like, okay, well, how much do I need to make? This is going to depend on your sample size, your number of samples, and things like that. Typically, they won't tell you like what volumes of things that they use, and so you need to figure out, okay, well, am I doing this in like a tiny Eppendorf? Am I doing it in a 96 well plate? Am I doing this in a giant beaker? And so you kind of have to just, this is where checking out other methods, thinking through how much of this, like what concentrations of things you have, various things like that. And again, going to other protocols and seeing what types of scales people are normally doing these things are. Once you figure out how much you need, then you can use like C1V1 equals C2V2 to figure out the concentrations, the amounts of the various components you need to add. Typically what I do is I start and I take those components that are in the solution and I make stock solutions of them. So maybe they have like sodium chloride, maybe they have tris buffer. So you can make, say, 5 molar sodium chloride and 1 molar tris buffer. And then you can dilute those using C1V1 equals C2V2, which is way easier than having to weigh out all of these various solids each time you go to make the buffer, especially if you just need a little volume of something. So find the different components, make stock solutions, and mix them together to make your final buffers. Okay, and then it really helps if you find someone who has done the protocol or at least similar protocols before. If they probably have more detailed notes because they had to do something similar to this in order to figure out how to do it in the first place, or they knew someone that was able to share their detailed protocol. And so really do try to find somebody that you could talk to, or maybe at least for parts of the experiment. If there are those various components of the experiment that then they can help you with, give you more detailed things like, okay, this is how you go about running a Western blot. And so you can do that part, that'll help you with that part of the protocol. And then you just have to figure out this other part of the protocol. Maybe someone else knows how to do that. Along similar lines, keep really detailed notes and write up a detailed protocol that you can use for yourself as well as share with your lab mates to save them from the hassle. And remember to pay it forward and pass on the knowledge that you gain. When you're going to design the experiments, so write out that really detailed protocol beforehand. Figure out what you need. Make sure you have everything that you need before you start. And remember that if you don't have everything that was in the protocol as written, there are often things that you can substitute to make it so that you can still do the experiments without the equipment. Make sure you know where everything is. If it's often if you have someone that can help you with this technique, maybe that's done similar parts, or maybe it's just you need another set of hands. That can be helpful. Also, talking through things with lab mates, even if they're not doing it with you, trying to like go over what you've come up with and say, okay, does this make sense to you? Would you do things differently? So try to just like get a sanity check on it before you actually go about trying it. And also, it's helpful to like don't rush it when you're coming up with things. Figure it out, sleep on it, look at it again, sleep on it, look at it again. Taking time to plan things out is going to help save you a lot of time, a lot of money, a lot of hassle. What I typically do is I design my experiments at least the day before, and then I sleep on it, and then I look at it fresh in the morning, and I write out really detailed protocols, and then I print them out, and then I work with them when I'm in the lab, and I write on them if I make any changes, if there was any sort of deviation from the protocol. And then what I do is then I transfer those to my notes and my digital notes and everything like that. But I plan things out ahead of time really well. And yeah. And then for the future, when you write methods papers, make sure you include a lot of detail so other people can recreate things. And if possible, publish your protocols on one of those sites, maybe even make a video on Jove, publish to one of those open access, like open wetware type things, and help other people out. And so, speaking of helping people out, I hope that this helps people design experiments. And good luck with your experiments. And yeah.